Hello learners, this is Parag Rastogi. I am working as a student professor in the Department of Computer Science and Engineering, RKGIT Ghaziabad. Today we will discuss about the topic project management on the operating system. But before starting the topic, first we will discuss about the operating system, the introduction part of the operating system. So what is operating system? As you know that operating system is a system software which acts as an interface between the user and the computer hardware. So this is a very basic type of definition that the interface between the system hardware and the user. But what is actually the interface is? Interface is a platform on which the operating system provides the functionalities to interact with the computer system. So it's just like a operating system through which you can use all the functionalities, all the resources of a computer system. The question arises that if there is no operating system, how we will operate a computer system? So it is just like if you want to switch on a fan, then you will push the switch of the fan so that you can start the fan. But if there is no switch, how will you start the fan? Maybe there is a circuit, maybe there is some wires through which you can connect the wires and the fan will start. But everyone don't know about the circuit structure, don't know about the how to combine the two wires and start the fan. So for this purpose there is a switch, and this switch provides the interface between the fan and the user. So in the similar way, the operating system is a system software which provides a platform so that we can interact with the computer hardwares. The next is what is system software. So there is a two type of software: system software and the application software. Application software are those softwares which are used for the specific purposes, like Excel, like Word, and like the PowerPoint, etc. But the system software are those softwares which provide the platform to handle, to manage, and to operate these type of application softwares. So that is basically what about the operating system. So I hope the operating system is very well understood by the users. So now come to the our topic, that is the process. So what is a process? Everyone know about the program. Program is a collection of instructions, and process is a entity which is basically a program which is in execution, and the execution of a process must progress in a sequential fashion. So process is just a dynamic entity, while the program is a passive entity. Means if we want to execute a program, then that executable entity of a program is said to be a process. A process is defined as an entity which represents the basic unit of work to be implemented in the system. Now, we will see the differences between the process and a program. Here, process is a dynamic object while the program is a static object. Now, what does it mean? The dynamic and static program is just a static entity which is just a collection of program, and it cannot be executed. While the process is a dynamic object, means it changes the state while executing. It consumes the resources like memory, input, output, resource management, process resources, and process management, etc. So for this purpose, process, we can say that process is a dynamic type of object. Next, process is a sequence of instruction in execution. We earlier said that process is an entity which is in which the program which is in execution is called a process. So process is a sequence of instructions execution, while the program is simply a sequence of instruction. That is, it is a set of instructions and it cannot be executed its own. Third is process loaded into the main memory. The processes are saved in the main memory of the system, while the programs are loaded into the secondary storage of the system. The next one is time span of process is limited, because every process is allocated a processor, and processor is allocated for a certain amount of time to every and each process. So time span of every process is limited, while because program is an passive entity, and it is a static type of nature. That is why the time span of program is unlimited. Process is an active entity and the program is an passive entity. So this is the basic difference between a process and a program, because it is very confusing about the students that what is the process and program. So program is just an instruction of instructions, a set of instructions, while the set of instructions, if we want to execute, that executable entity is called a process. Now the different states of a process. While we executing a process, the process undergoes several type of states. When a process executes, it passes through various stages. These stages may differ in different type of operating system, and the name are also not standardized because different operating system use a different type of names. So there is no specific type of name of the states of a process, but for the ease and for the convenience, we define 5 types of stages in a process. In general, a process can have one of the following 5 states that we can use. The first is the starting state. The starting stage is the initial state when a process is first started or created. This is the very basic or very initial phase in which we can start a process, or we can say that we create a process. So this basic stage is said to be as the starting stage of a process. Second is the ready state. Ready state is the state where we can where the process is waiting for some processor so that they can start running. So ready process are waiting to have the processor allocated to them by the operating system so that they can run, because every process waiting for the processor so that they can start its execution. So in this ready state, the processes are waiting for the CPU so that the execution of the process may be started. Process may come into this state after the start state, or while running it by interrupted by the scheduler to assign the CPU to some other process. So in this ready state, the process comes in 2 ways. Either after the starting state of the process, or if the scheduler halts or interrupt any process and assign that process into this ready state. So these are the 2 types, there are 2 ways in which a process can enter into the ready state. The next one is the running state. Running state, once the process has been assigned to a processor by the operating system scheduler, the process state is set to running and the processor executes its instruction. This is the third state in which the processes allocates the CPU so that they can start their execution, and in the running state all the processes are allocated a CPU and they can start running their execution. Fourth is the waiting state. In the waiting state, the processes are waited for some resources like input-output resources, memory management, or some other files or directories, so that they can use these resources for their execution. So process moves into the waiting state if it needs to wait for a resource, as waiting for user input or waiting for a file to become available. So it is basically the waiting state in which a process waits for some resources, and these resources can be of any type. Means it's a user input, it is a file, it's a directory, it's a memory allocation. Any type of resources the process wants goes into the waiting state. And the final stage is the terminated or the exiting state. This state is the final stage in which a process terminates or finish its execution and comes into this state after all the execution finished. Once the process finishes its execution or it is terminated by the operating system, it is moved to the terminated state where it waits to be removed from the main memory. And after the termination of the processes, the process is are waited from to be removed from the main memory, because the process has finished their execution, and after finishing of the execution, process are removed from the main memory. This is the basic building block diagram of all the 5 stages. that means first is the starting state. After the starting state, the process goes to the ready state, in which ready state all the process are waiting for the allocation of the processes. And after the ready state, the process goes to the running state. In the running state, processes receive the processes, and they start their execution. If the execution successfully begin, the process comes to the terminated state and terminates. And if there is any halt by the CPU or the processor, or there is any error in the running state, then the processor goes back to the ready state and waiting for the process or the resources. Or the running from the running state, the processor goes to the waiting state. If there is no CPUs allocated to any process, it comes to the waiting state. Or in the final state, if all goes well, the processes goes to the terminated state and finish their execution. So this is the life cycle model of any process, and it comes with the 5 stages from starting or initial state to the terminated state. Next is the process control block. As we know that the operating system supports the multi-programming. Most of the operating system like Windows, Unix, Linux, all the operating systems supports multi-programming. So it is very necessary for an operating system to find out the processes among the different number of processes. So for supporting of multi-programming, operating system creates a PID, means a process identification number, so that it can identify any process. While creating a process, the operating system performs several operations. To identify the process, it assigns a process identification number, which we call as the PID, to each process, so that we can identify each and every process among the number of processes. Just like we assign roll numbers to the students in a class. Suppose they are 70 or 80 students in a class, and we don't know about their names. So there is only a roll number, which is a unique identity, which through which we can identify any student. In a similar way, in the number of processes or in a multi-programming environment, the operating system identify each and every process through its PID. So for this PID, the process control block is to be used. As the operating system supports multi-programming, it needs to keep track of every process in the ready queue. For this task, the process control block is used to track the process execution status in this life cycle. So for this purpose, the process control block is introduced. There are the number of states in the process control block. First is the process state. Process states identifies all the states from ready, running, waiting, terminated, or any other state. Means we can identify in which state a process currently resides. So from the process states, we can identify the state of every process. Second is the program counter. Program counter is type of register which indicates the address of the next instruction to be executed. Means after one instruction, which will be the next instruction to be executed by the CPU, this will be introduced by the program counter. Third is the CPU register. CPU register are the registers which includes accumulators, stake pointer, general purpose registers, all the registers which are used in the execution of a process. So all these registers or the intermediary memory locations are termed as the CPU registers, and it identifies by this CPU register state. Fourth is the CPU scheduling information. CPU scheduling includes process, pointers to scheduling queues, other type of scheduling parameters which identify the structure, how to schedule the process so that they can execute in a sequential manner. For this purpose, the CPU scheduling information is to be used. Next is the memory management information, which stores or define all type of memory management schemes, all the spaces in which the processes are stored. It includes page tables, segmentation, fragmentation, value of base, and limit registers. All the information about the memory management techniques, paging, segmentation that we are used in our memory management. All these memory management information are contained in this memory management information stage. Six is the accounting information. It includes amount of CPU used, how much amount of processor is used during the execution of the processes, the jobs or process number, which process is allocated in which state it is running. It is either process P1 is running in the initial state, or P3 is in the execution state, or some other process in some other state. All these information, all the information about the CPU allocation, all the information about the how much processor is used, all this information is contained in the accounting information state. And the next is the input output status information, which includes all the input output operations of a process. It includes the list of input output devices allocated to each and every process. Next stage is the context switching. Context switching is a very important part in the operating system, because it is a technique, or it is a method that is used by the operating system to switch a process from one state to the another state. Because during the execution, every process undergoes different type of states, as we understand earlier in the process states. So context switching is a technique through which we can move a process from one state to the next state, or next state to the another next state. This information is handled by the context switching method. When switching performs in the system, it stores the old running process status in the form of registers. So when we perform the switching, the CPU stores the running status, the running old running process status in the form of registers, that we can store the status of the previous or older process while executing, and we start execution of the new process. We store the previous address, store the previous process status in the memory, and we start the execution of the next process. While a new process is running in the system, the previous process must wait in a ready queue. So when we start the execution of the new process in the system, the previous process, the older process that we executed earlier, must wait in the ready queue for the allocation of the processor. The execution of the older process starts at the point where another process stopped it. So it begins from where we stopped the older process. It defines the characteristics of multitasking operating system in which multiple processes share the same CPU to perform the multiple tasks without the need of the additional processor in the system. So in this way, we can hold the address of the previous executed or previous stopped process, and we side by side we begin the execution of the new process also, so that when we restart the older process, we begin from where we stopped the older process. So this is done by the context switching state. Now this is the example of the context switching, how we perform the context switching. So suppose that there are multiple processes are stored in a process control block. We have a process control block, and we have a number of processes in the PCB. One process is in running state, execute its task with the use of CPUs. One process is running in the running state, and it is managed by the processor. As the process is running, another process arrives in the ready queue. Means side by side, simultaneously, when a process in the running state, another process enters in the ready state, in the ready queue, which has high priority of completing its task using the CPU. So there are two types. There is a scenario in which we already started execution of the process, but we find that some another process enters in the ready queue or in the ready state, and it has the higher priority. So What we do, we halt or we preempt the currently running process, and we give priority to that higher priority process, and we start execution of that high priority process and halts the currently running process. Here we use context switching. So context switching, what context switching do in this case? Context switching changes the state from one state to the another. So in this way, context switching switches the current process with the new process, require the CPU to finish its task. While switching the process, a context switch saves the status of the older process in the register. So we stop the older process and we begin the high priority process in execution. So the status of the older process which we have preempted is its status is saved in the in the form of registers, and when the process reloads into the CPU, it starts the execution of the process when the new process stops the older process. If we do not save the state, suppose we do not save the status of the older process in the in the register, so in this case we have to start its execution at the initial level. We have to start the execution of the older process from the beginning, because we don't have any type of status, we don't have any type of information about the older process. So in that case we have to start the execution of the older process from the beginning. So this is the advantage of the context switching, that we save the status of the previously running process in the form of registers, in the registers, so that we can start the process execution of the older process from where we stopped. So in this way, context switching helps the operating system to switch between the processes, store or reload the process when it requires executing its tasks. Next is the process scheduling. Process scheduling defines about the scheduling about the execution of the process, means the order in which the process come in the ready queue and starts their execution in a sequential manner. So for this execution we need process scheduling algorithms. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and selection of the another process on the basis of a particular strategy. And this strategy may be in the form of algorithms that we will study in the subsequent sections. What is CPU scheduling algorithms? These scheduling algorithms define the strategy on which we schedule the processes for the executions. Process scheduling is an essential part of the multi-programming operating system, because there are a number of processes in the multi-programming. So we have to define, we have to set an order in that order how the processes comes one by one and start their execution. So for this purpose we have to schedule the processes, and for this process scheduling is very much essential. Multi-programming operating systems in the multi-programming system allow more than one process to be loaded into the executable memory at a time, and loaded the process shares the CPU using time multiplexing. So for define a particular strategy we need process scheduling. From process scheduling we can start execution of the processes, number of processes in a multi-programming environment. Next is the schedulers. What is scheduler? Scheduler is the special type of system software which handles the process scheduling in various ways. The main task of the schedulers are to select the jobs to be submitted, because there are number of jobs, number of tasks, and how we select any task or a job, it is decided by the schedulers. So the main task of a scheduler is to select the jobs to be submitted into the system and to decide which process to run. Means there are number of process, and how we will define which process is running first. So this is decided by the scheduler, which particularly select a process to run. And there are three types of schedulers in the schedulers. The first is the long-term scheduler, second is the short-term scheduler, and third is the medium-term scheduler. Now we will study about all these schedulers. First is the long-term scheduler. The long-term scheduler is also called a job scheduler, as a long-term scheduler determines which programs are admitted to the system. Means we have to select the program so that the program can start its execution. So this is done by the long-term scheduler, and that is why it is known as the it is also known as the program schedulers, because it selects processes from the queue and loads them into the memory for execution. This is the main task of the long-term scheduler, because it picks the processes from the ready queue, loads them into the queue, and begin their execution. Process loads into the memory for CPU scheduling, because CPU scheduling, after that the jobs are scheduled in the queue, they are picked up by the process scheduling and start their execution. The primary objective of the job scheduler is to provide a balanced mix of jobs. There are a number of jobs, so different type of jobs are available. So we have to accommodate all types of jobs. Means the job may be a input output bound or a processor bound. So the long-term scheduler is provide a balanced mix of these two types of jobs. It also controls the degree of multiprogramming. If the degree of multiprogramming is stable, then the average of process creation must be equal to the average departure rate of process leaving the system. That means if the number of processes are coming in a certain number, then the similar number of processes are to be out from the system, leaving the system. Next is the short-term scheduler. Short-term schedulers are an important scheduler, and it is called as the CPU scheduler because its main task is to increase the system performance in accordance with the selection of criteria. We have a selected criteria, and according to that criteria, we have to enhance the performance of our system. So the short-term scheduler is called as a CPU scheduler. And it is a very much important in comparison to the other schedulers. It is a change of ready state to running state of a process. CPU scheduler selects a process among the processes that are ready to execute and allocate the CPU to one of them. Third is a medium-term scheduler. Medium-term scheduler is a part of swapping because its main task is to swap the processes from one state to the another state, from one location to the another location. It removes the process from the memory. The medium-term scheduler is in charge of handling the swapped out processes. It swapped the location of a process from one state to the another state, or from one location to the another location. A running process may become suspended if it makes an input-output request. If the input-output request is made available, then we can suspend any type of running process, and the process is going to the waiting state or the terminated state. Suspended process cannot make any progress toward the completion because the process is suspended, and if the process goes into suspended state, then in that situation the process cannot make any progress and it will be suspended by the CPU. In this condition, to remove the process from memory and make space for other process, that means we have to remove that suspended process, and that particular location, the space created in such situation, we allocate that space to some another process so that the another process can start their execution, and that suspended process is removed from the main memory. The suspended process is moved to the secondary storage, and in that case, the suspended process removed from the main memory, that space is allocated to the some other process, and that suspended process is sent back to the secondary memory storage, because in the future if we want to use that suspended process, we can easily recover it or fetch from the secondary memory. This process is called swapping, and the process is said to be swapped out or rolled out. So all this swapped out, rolled out, and swapping is done by the medium term schedulers. So these are the different specifications of these three schedulers: the long term, short term, and the medium term schedulers. Now move to the comparison among all these three schedulers. In the long term scheduler, it is just a job scheduler, because it's just select the different type of jobs and send to the memory for the selection of the process for running. Short term scheduler is also called a CPU scheduler, and its main task is to enhance the performance of the system. That's why it is called as the CPU scheduler. Medium term scheduler swapping is basically responsible for the swapping process. That's why it's a process swapping scheduler. Long term scheduler speed is lesser than the short term scheduler. The short term scheduler speed is fastest in comparison to both the long term scheduler and the medium term scheduler, and speed in the medium term scheduler is short, both short and long term scheduler. The speed of the medium term scheduler is slower in comparison to short term and the long term, both the schedulers. Means it is the slowest type of scheduler, while the short term scheduler is the fastest among all these three. Third point, it controls the degree of multiprogramming. The long term scheduler controls the degree of multiprogramming, means the multiprogramming controlling mechanism is available in the long term scheduler, while the short term scheduler, it provides lesser control over the degree of multiprogramming, and in the medium term scheduler it reduces the degree of multiprogramming. Means the long term scheduler controls the multiprogramming, controls the degree of multiprogramming. It provides less control in the short term, while in the medium term scheduler it reduces the degree of multiprogramming. Means the multiprogramming capability is very much lesser in comparison to short term and the long term available in the medium term scheduler. Fourth, in the long term scheduler, it is almost absent or minimal in time sharing system. Minimal or almost absent means time sharing system. In the time sharing systems, the long term scheduler is almost minimal, or we can say it is a very it is almost absent. But in the short term scheduler, it also minimal in time sharing systems. Means time sharing systems, the short term scheduler is it behaves just like the long term scheduler. In the medium term scheduler, it's a part of time sharing systems. Means time sharing systems, medium term scheduler is available in the time sharing operating systems. But the long term and short term both have the no role in the time sharing systems. And the last is in long term scheduler, it selects process from pool and loads them into the memory for execution, because the long term scheduler select the jobs, select the processes and loads them into the memory for execution. So it select the process from a bunch of processes and stored them into the memory, while in the short term scheduler it select those processes which are ready to execute. So the short term scheduler, the task of the short term scheduler is very much crucial, because it select those processes which are ready for the execution. So it's the main task to select the processes and send back for the execution. But in the medium term scheduler, it can reintroduce the process into memory and execution can be continued. So the reintroduction facility is available in the medium term schedule. So this is the basic comparison among the three schedulers, the long term, short term and the medium term scheduler. Next is the scheduling criteria. We have discussed what is process scheduling, how we schedule the process in a sequential manner, but how this criteria is performed. What is the basic mechanism of scheduling? So scheduling can be defined as a set of policies and mechanisms which control the order in which the work to be done is completed. Means the working of scheduling is to define the policies, define the mechanism through these mechanisms we we can control the order of the processes, because there are number of processes, and we have to develop a mechanism so that we can control the execution of number of processes. For this purpose, we need scheduling criteria. The scheduling program, which is a system software concerned with the scheduling, is called the scheduler, because the program which is responsible for this scheduling criteria is called as the scheduler, and the algorithm or the policies which define this criteria is governed by the different type of scheduling algorithms, which we'll discuss in the subsequent sections. Various criteria or characteristics that help in designing a good scheduling algorithms are as follows. There's the scheduling criteria that we have to keep in mind. First, the CPU's utilization. This is very much essential for process scheduling or the job scheduling, that CPU must be utilized in a maximum way. The CPU should not be sit idle. So the utilization of a processor is very much essential while performing scheduling algorithms. A scheduling algorithm should be designed so that CPU remain as much as possible busy. It should make efficient use of the processor. Second point is the throughput. Throughput is, we can say, that it's the amount of work to be done in a given time period. We need maximum throughput in our scheduling criteria. So our aim is to maximize the throughput of any system. Throughput is the amount of work completed in a unit of time. In other words, throughput is the process executed to a number of jobs completed in a unit of time. So in a particular time unit, we have to perform number of tasks, and these number of tasks completed in a given unit of time is said to be as the throughput of that system. The scheduling algorithm must look to maximize the number of jobs, processes per unit time. The third point is the turnaround time. Turnaround time refers to the time between the moment of submission of a job or a process and the time of its completion. So turnaround time is basically the time interval between the submission of that job and completion of that job. The difference of that time duration is called as the turnaround time. And in the subsequent sections, then when we evaluated the CPU scheduling algorithms, we need turnaround time to be calculated. So for this, turnaround time formula is given by turnaround time is equal to completion time of any process minus the arrival time of that process. So the difference will be called as the turnaround time of the process. Next point is the waiting time. Waiting time, it's the time a job waits for a resource allocation when several jobs are completing in multi-programming system. So waiting time is the time that that a job waits for its completion or the allocation when the several jobs are competing for the execution. The aim is to minimize the waiting time. Just like the the throughput, that means we have to increase the throughput. Our aim is to maximize the throughput. In the similar way, our aim is to minimize the waiting time of any process, because it is very much essential that a process must wait in a very minimal time, so that the time could not be increased. So to calculate the waiting time, we have a formula. Waiting time is equal to turnaround time minus the burst time. Burst time means when the process completes its execution. That is said to be as the burst time. So turnaround time minus burst time is called the waiting time of that process. And the last is the response time. Response time is the time taken to start responding to the request. A scheduler must aim to minimize the response time. Just like the waiting time, we have to minimize the waiting time. Similarly, we have to minimize our aim, our main task is to minimize the response time while performing the execution. So we have to keep in mind that we should maximize the throughput, we should minimize the waiting time and the response time while performing the scheduling algorithms. Next, the scheduling algorithms. There are two types of scheduling algorithms when we are talking about the CPU scheduling algorithms. The first is the non-preemptive, and the second is the preemptive approach. Non-preemptive, here the resources cannot be taken from a process. In the non-preemptive approach, we cannot snatch a process. We cannot snatch the resources from any process until it completes its execution. So non-preemptive, uh, if a processor is allocated to the process, then the process completes its execution without any intervention. We cannot snatch the resources from that particular process. The switching of resources occurs when the running process terminates and moves to a waiting state. Only that it will stop. Otherwise, we cannot stop the non-preemptive processes. While preemptive process, there is a situation when we stop the execution of a currently running process and we give the priority to the high priority process. In this case, we have to preempt, we will preempt the currently running process, and we give CPU switching to the high priority process. Here the operating system allocates the resources to a process for a fixed amount of time. We have to give the fixed amount of time a process to a particular process. Unlike in the non-preemptive, there is no boundation of the time boundation is not given. But in the preemptive approach, we have a fixed amount of time for every process. During resource allocation, the process switches from running state to the ready state, or from waiting state to the ready state. This switching occurs at the CPU may give priority to the other processes and replace the process with high priority process. That means if a process has the high priority and it is in hurry to complete its execution, then we will stop the currently running process and give process to the that high priority process. And this phenomenon is called as the preemption. So in this case, it replaces the process with high priority with the running processes. Now, the summary about the CPU scheduling, we have gained some points during this discussion. The purpose of scheduling algorithm are as follows. The first, we will maximize the CPU utilization. That is, the CPU should not be sit idle. Second, fair allocation of CPU. Every process will allocate equal amount of CPU. So the allocation of CPU to every and each process is very much essential. Third, maximum throughput. We will try to achieve maximum throughput during the process execution. Fourth, minimum turnaround time. Our aim is to minimize the turnaround time during the execution. Fifth, minimum waiting time. We will try to best to minimize the waiting time of any process during the program execution. And sixth, minimize the response time so that we can achieve the better utilization of our processes. So these are the 6 criteria that we have to follow, that we have to keep in mind during the CPU scheduling, that if these criteria are fulfilled, we can say that our scheduling is performed in a good way. So I hope you will enjoy the lecture, and your doubts about the operating system, the process management, and different type of other topics will be cleared. So in the subsequent sections, we will discuss about the various type of scheduling algorithms, like first come first serve, shortest job first, and round robin also. So for this, we will prepare some another lecture for to discuss about these topics. Uh, Thank you so much. अपने आप ही to.